Hello everyone, we'll see the next topic in the module 2 in the data structure using C++. The concept is stack. So stack is also a kind of a data structure which is used to store the data. Then what is a stack? A stack is a linear list in which insertion and removal takes place at the same end. So this end we can call it as a top and the other end we can call it as a bottom. Here insertion is nothing but a push operation in the stack. Removal in the sense that is nothing but pop operation in the stack. Pop is nothing but deletion of an element from the stack. And the stack always work as a LIFO operation, last in first out, in the sense the element which is inserted at the last will be deleted first. So we can see in the figure A there are 4 elements A, B, C, D. So already told you insertion always done at the same end, deletion is also done at the same end. So that end is nothing but top. So if I want to insert the A, I need to insert from the top. Then after that B, C, D. So which element is last here? D. So as per the stack, it works as a LIFO, in the sense last in first out. Which was the element that was inserted last? That is D. So that is the first element that we can pop, in the sense delete. So we can delete D first, C second, B third and A at the last. Even though A is the first element, but it is deleted at the last because it always works in the LIFO operation, stack. So this is how the stack works. So next we'll see the abstract data type of the stack. So what are the different operations that are present in the stack? That is, first one is empty. Empty is nothing but it returns the true if the stack is empty, else false. Then size, this returns the number of elements that are present in the stack. Then top is nothing but the element that is present at the top of the stack, that is nothing but the element that is inserted at the last. Next one is pop is nothing but deletion of element from the stack is pop. Push of x is nothing but element that we want to insert. Next is abstract class of a stack. So we already discussed what is abstract class. So what are the different types of operations that are present in the stack? Again the same operations: empty, size, top, pop, push. So this is the abstract class of the stack. So next is array representation. So by using the array, how we can perform the operation of the stack. So a stack is linear list, already shown, said that the restriction that addition and deletion takes place at the same end. So we need to derive the class from a stack and an array list. So we are using here a class called derived array stack, and we are using a constructor derived array stack, which is nothing but a constructor. We have already done this. So constructor is nothing but initializing the objects of the class. So next we can see the below program. So class derived array stack implements array list as well as stack class, but how? Publicly, in the sense we can access all the members of array list and stack. So the members of a derived array stacks are derived array stack, that is nothing but a constructor. Then we have got empty method, size method, and top method, pop method, and push method. We already know what are these methods, but we are implementing from the array as well as stack. Means by using those methods we can perform these operations. So this is how array representation work. So next we will see class array stack that implements a stack. So we have got from private members, that is stack top, in the sense the current element of the stack. Then array length, then what is the capacity of the stack, then t star element, this is nothing but the element that we want to insert. And we have got some public members of array stack that are nothing but constructor and destructor. And the first one here is empty. So if the stack is empty, it returns false. No, it returns true. So first we need to check that. So int size, it returns the number of elements that are present. So that is nothing but stack top plus 1 gives the exact size of the stack. Next is top. So first we need to check the stack is empty or not. If the stack is not empty, it will return the top element. Then pop. Here also we need to check the stack is empty or not. If the stack is not empty, it will delete the element from the stack. Next one is here push operations, where we can push the element in the stack from the top. So this is about the array stack. So next we will see linked representation. So we already seen what is a linked list, so how it works, so how the insertion and deletion takes place. So the insertion and deletion in a linked list are totally different when you compare with the other things. So first we need to study about them, then we can understand this linked list representation, which is used to perform the stack. So whenever we are using a linked list, that is nothing but a chain to represent a stack. So if we are using a stack by using a linked list, first we need to decide either we are using right end or left end, because a stack always operates at the same end, insertion and deletion. So if we are using a right end at a linked list, means we need to use get size minus 1, insert size comma the element, and erase size minus 1 operations. If we are using left end of the chain, means we can use the operation or a method get 0, insert 0 comma the element, and erase 0. Then only we can perform the operations as push, pop, those kind of things. Here we can see the class linked list, which is implementing the stack and the chain node publicly, means we can access the members of the stack and the chain node. So here the push and pop and these are the operations are nothing but insertion and deletion operation in the linked list. Whatever we have seen in the previous linked list, the same operation will be performed here by using this stack. So this is about the stack